Right, let's get this party started. I hope you're all excited. I certainly am. First of all, I would like to welcome all of you to tonight's FameLab Finals here in Bern. A warm welcome to all of you in the audience, both here in person, who made it despite the rather gloomy weather. I would like to say British a bit. And all the people following us online through the live stream. Also a big welcome to our jury members who I will be introducing in a moment. And naturally, a very big welcome to the stars of tonight. The 10 finalists who have already proven themselves in the regional heats and are now competing for the national title. Before I go on, I would like to give the word to Philip Schneider from the UK Science and Technology Network from the British Embassy.
Good evening, everyone. Grüezi miteinander. Bonsoir à toutes et à tous. It's a real pleasure to welcome you to the FameLab Switzerland final here in Bern today. And apologies for the British weather, indeed. FameLab has a very special connection to the UK. It began 20 years ago in 2005 at the Cheltenham Science Festival as a way to make science engaging for everyone. Just 2 years later, in 2007, thanks to the partnership with the British Council, it went global, reaching more than 30 countries and inspiring thousands of scientists and engineers to share their research with clarity, creativity, and charisma. For 15 years, the UK helped shape this international movement, training and connecting science communicators worldwide. That's why the British Embassy is proud to continue supporting FameLab in Switzerland today and also in the future. It reflects our belief that science should not only be excellent, but also accessible. This event also reflects the strong partnership between Switzerland and the UK in science and innovation. Our both countries share a commitment to excellence and openness. Through our science and innovation memorandum of understanding we have between our countries, we are working together on cutting-edge areas like engineering biology, semiconductors, life sciences, or clean energy. Over the past few years, UK and Swiss research councils have launched joint funding calls with millions of pounds and francs, enabling collaborative projects in areas such as clinical trials or different frontier technologies. We've also seen vibrant exchanges through innovation missions and expert dialogues, from quantum and research security to cell and gene therapy. So, coming back to FameLab, this complements this work by building the skills that make science accessible and exciting at the same time. Again, it's about clarity, creativity, and charisma, the same qualities that drive collaboration and innovation across borders. So, to all the finalists today, congratulations on reaching this stage. We can't wait to hear your stories. And to the organizers, thanks for inviting, to the judges and partners to make this Swiss final possible here in Bern today. Have a fantastic science evening and let's get started.
Okay, so I'm sure you've already noticed I am your host tonight and will be guiding you through this wonderful evening. My name is Iris Sutter. During the week I work at Sciences et Cité. On the weekends I'm a volunteer for REACH, both of which are science communication organizations, so if you have any questions, ask me later. But I ought to admit, although science communication has been a passion of mine for quite some time, and my recent career in science communication, I've actually never made it to the FameLab so far. So I'm super excited to be here tonight with all of you and to experience the FameLab myself for the first time. Now if we can go on a slide. So I'm sure most of you already know what FameLab is all about. After all, you're here. However, in case you were dragged here by a friend and have no idea what's going on, so FameLab is an international science communication competition, and one of the biggest ones at that, with over 35 countries participating and thousands of scientists involved. In these competitions, participants have 3 minutes only, and we are very strict on the time limit there, to present their favorite topic to you. However, unlike science slams, which some of you might be familiar with, participants have to completely rely on themselves. So they are not allowed any slides or anything similar to support their talk, but they may have some props. This way, all the attention is on them and the science they are communicating. Now, the judges will be evaluating the participants according to the 3 C's. The 3 C's standing for content, is it scientifically accurate? Clarity, is it understandable and accessible? And charisma, is it fun and entertaining to watch? And are they able to share their passion for the topic? Now let me quickly introduce you to the judges tonight. So on the very right side, for you on the right side is Carl Emerson. Maybe you can wave. Exactly. So Carl Emerson is a senior organizational development specialist and leadership advisor, known for his psychologically informed approach to complex team dynamics and personal transformation. Combining expertise in emotional intelligence, communication, and strategic facilitation, he helps leaders navigate change, uncover hidden needs, and build trust, agility, and authentic influence. With extensive experience designing reflective, discussion-based learning, Carl bridges high-level strategy with human insight. As a skilled storyteller, he uses real-world examples to bring ideas to life and inspire lasting motivation. Very inspiring. One to the left is our female power tonight, Katrin Hürlimann. She's an experienced communication expert specializing in science communication and public relation at ETH Zurich's Department of Health Sciences and Technology. Her expertise lies in the strategic development of communication concepts and making complex scientific topics accessible to diverse audiences. Katrin especially appreciates when scientists succeed in presenting their research so clearly and engagingly that its core ideas are immediately understandable. With strong skills in media relation and external communication, she brings valuable insight to her role as a juror at FameLab, supporting innovative and impactful science communication. Then one again to the left is Adarsh Sitapati. He studied molecular biology at the University of Basel, then biology and chemistry at the University of Zurich in order to teach these subjects in high school. He then shifted from teaching STEM in high schools into freelancing as learning coach, life coach, and web designing. It's quite a break. Adarsh maintained a step in science by teaching regularly biology courses at the Life Science Learning Center in Zurich. He considers entrepreneurship an art and sees personal lifestyle as a piece of art. Very nice. And the last judge tonight, last but not least, is João Pequenau. He leads the CERN Media Lab, which is the creative group at CERN that blends technology, science, and storytelling to visualize and play with particle physics. A physicist by training, he designs immersive environments, interactive exhibitions, and data-driven visuals, and has helped shape outreach for CERN and experiments. His animations and installations have been featured by major media and science centers and research institutions worldwide. João directed Phantom of the Universe, an award-winning planetarium show about dark matter. He is also president of the CERN Dramatic Arts Club and an improv coach, training science communicators around the world to become engaging guides using techniques from improv and the dramatic arts. As a frequent speaker and mentor, he leads with a coach's mindset and brings a playful, rigorous approach to making complex science accessible. So that's the jury, and we are extremely grateful to have all of you here and hope to profit from your experiences and capabilities. They have the privilege, but also the duty to ask questions after each of the 10 talks. However, the jurors are not the only judges tonight. In fact, you, the audience, also get to decide who is your favorite speaker. How exactly that works, I will explain later before the break when it's time. However, just so you already know, and you can keep it in mind while listening to the presentations. So, finally, we made it. For our first speaker, his name is Nicholas Angelides. He's a postdoc at the University of Zurich in dark matter detection. He just started his second postdoc in astroparticle physics at the University of Zurich, continuing the search for dark matter with deep underground experiments. Since 2017, he's been a member of the LC experiment, for which he's held many team leadership roles in building and operating the world's most sensitive dark matter detector. Prior to physics, he trained in fine arts and sculpture. Today, he combines his love for philosophy, art, and science through a number of outreach and interdisciplinary activities. In communicating abstract scientific concepts, he employs a number of digital and physical media and enjoys exploring unique ways in which information is experienced. So the stage is yours, Nicholas Angelides. The title of his talk, What's the Matter with the Universe?
Awesome, thank you. I'm ready to go whenever the timer is ready. I am one of hundreds of physicists that spend their lives looking for dark matter, something invisible, so far not confirmed form of exotic matter. But why? How did something practically invisible become one of the biggest open problems in physics? Well, it's because indirect evidence for the existence of dark matter is everywhere we look. It comes from looking at the bits of the universe that we can actually observe, and specifically how they move under the force of gravity. In this case, to demonstrate, I'm using this piece of rope, which turns the force of gravity of one object into the force that keeps another in orbit. If the rotation's too fast or the force of gravity too weak, then the orbit's not stable and it would fly apart. If the rotation's too slow and the gravity's too strong, then the rotation would collapse. This fine relationship between how an object rotates another and the force of gravity between them is what Swiss astrophysicist Fritz Zwicky used to show something strange about the universe. He looked at the comet cluster, he counted the stars and galaxies in it, and that gave him an estimate of the amount of gravity. Then he tried to balance that with how fast the cluster was moving, only to find a bit of a problem. The matter he could see did not provide enough gravity to support how fast the cluster was spinning. Now, Zwicky was stubborn, and he did not like admitting that he got something wrong, so his conclusion was strange, and it was that most of the matter in that galaxy cluster is actually invisible, but still quite heavy. Invisible in that it does not absorb or emit any light, dark. This dark matter would provide that extra gravity needed to now support that much faster orbit. But everybody thought Zwicky was crazy, and it took over 40 years for some to start changing their mind when Vera Rubin started making similar observations now at the scale of individual galaxies. Not just one or two, but every single galaxy, big or small, young or old, were all spinning so much faster that should have been possible, well, without taking into account some dark matter to keep the system together. Vera Rubin's work was essential in mapping the distribution of dark matter in the universe, telling us there's over 5 times more of it than known matter, which brings us to today, where we can look at how our own galaxy rotates and estimate how much dark matter is right here, right now. So Fritz Zwicky was crazy enough to spot it. Vera Rubin was smart enough to quantify it. We need to get creative enough to detect it. Thank you very much.
Very good. Thank you. Love that. Entertaining. Really, really very interesting. Quick question. How relevant is dark matter to me? How important?
So day-to-day, dark matter by definition would not interact. So it's something invisible. Without it, our galaxy would be flying apart. So it's one of those hidden comforts, I'd say, about our galaxy. We wouldn't be here without it. Today, right now, for you, I guess you can benefit from the inspiring stories of some incredible physics that we're able to do. Of course.
How would society be impacted after dark matter is detected?
That's a very good
Oh,
question.
that's even in rhyme. I didn't try this, but...
So dark matter by mass makes 5 times more of our universe than anything else. Its specific behavior at the earlier times of the universe, when everything was a big soup that was boiling, that behavior is really interesting in telling us how those moments went right after the Big Bang. The cosmic microwave background, which I think we'll hear about in a second, is a picture of that Big Bang but 100,000 years after the fact. Being able to interact with dark matter will take us so much closer to that beginning of the universe, since it was there and it kind of decoupled or came out of that soup of hot particles much, much earlier. So what we're hoping to find there is more information about how our universe came to be.
Great presentation, thank you. I actually made a documentary exactly about that thematic, Perfect. So I have to challenge you here.
Please.
So, as you know, there are 3 different ways for us to look for dark matter. Astrophysical observations, which you talked about,
yes.
deep underground experiments, in which I believe you work on, and detector experiments with colliders, in which, well, I come from a place which works on that. So far, we have found nothing.
Correct.
So, what if dark matter doesn't really exist and is just a mathematical construct for our comfort, theoretical comfort?
So, we as particle physicists love to think about the fundamental components. So, if dark matter exists, then we are confident in its ability to form particles in a similar way than everything else, unless it's something really, really strange, as you say, in which case we're completely looking in a dark room for a black cat. The kind of evidence that we have is fantastic in convincing us that something's wrong, right? So we have to start somewhere. And what we're doing in these accelerators and in these experiments is going after the most likely, but also the easiest hypotheses to test. We're not really overextending the field and suggesting looking for dark matter in places where we wouldn't expect strong theoretical motivation to exist. So we're grateful to our colleagues that spend lots of time writing papers that we can then go and chase after. So I hope that answers your question.
Also, thank you from me. As I'm not a scientist, I was so glad you had the stars and showed to me and had a visualization where I also could understand what the topic is about. So thank you so much.
Of course. Thank you for listening.
Thank you, Angelikos. quite some tough questions. You need to be prepared. Okay. Next up is Lucas Hermida Peña. He is a technical student in aerospace engineering at CERN. He originates from the Canary Islands in Spain and has now finished his studies in aerospace engineering at the same time that he works at the CERN in the HL-LHC project, the last update of the LHC. For those who don't know, LHC stands for Large Hadron Collider, right? Yeah, good. Yeah, I'm not a physicist. He's participated in several talent programs such as the Generación Talento and Generación Propósito, and won several entrepreneurship awards such as Inspiro and Pond Up Store 2023, as well as being part of and participating in various local jams on sustainable urban development. In his fourth year of university, he's founded a company called LuxSit, whose objective is to create light drone shows with their in-house manufactured drones made with recycled materials. He has a strong commitment to sustainability and social impact, and seeks to create positive change in his community and beyond. Welcome, Lucas, and his talk, The Universe's Longest Running Show.
Okay, I'm ready. It looks like we can watch everything on Netflix these days. Thrillers, comedies, even shows that are 10 seasons too long. At some point you can stop, it's enough. But there's one show that's been running for nearly 14 billion years. And you don't need a Netflix subscription to watch it. You just need an old-fashioned radio. To turn it on here, I think. Recognize that sound? Hidden in that static is the oldest broadcast in the universe. Most of it is just random electronics, but about 1% of it is special. They are photons that come from the very beginning of the universe, arriving into this exact room right now. And here's the funny part. This discovery wasn't made in a very fancy lab. It was made in the 1960s at Bell Labs. 2 engineers were testing an antenna, a very large one, actually, and they kept hearing a weird noise. Where is this coming from? They tried to clean it. No way. The noise was still there. They thought they were birds. They removed the birds. The noise is still there. So what is it? Turns out this noise was actually the solution. It was actually something so special that it deserves a FameLab talk. This was that when they found out this sound, they could see something new. But it was by accident. They were not actually looking for it. They tripped over it. So what is it? In the early universe, everything was so hot that atoms couldn't form. But then, as the universe progressively grew and cooled down, light could finally escape, carrying a baby picture of the universe. They called it microwave background radiation, which is a terrible name, but scientists are used to that, so that's okay. That light that nowadays we can study with our telescopes shows a very, very homogeneous picture, but with very tiny variations. In these tiny variations, we can spot such marvels as the shape of the universe, its structure, its components, and its age, from just an accident, which I think is really beautiful. So the next time you hear one of these noises, or you are at your grandma's house and you're watching one of those very old TVs, don't just hear the noise. See the first light of the cosmos, the greatest show and longest running show ever, 14 billion years. And honestly, compared to that, Netflix is just the pilot episode. Thank you.
I'm going to start. Thank you, Lucas. I really, really like the storytelling approach of your presentation. you had me from like the start to the end, and you always implemented some pictures where I could really imagine what your science is about. That was great. Thanks.
I add something to it. You also used your prep effectively because, I mean, in day-to-day life, we can relate to this background noise. And if you would said background noise in the data as a scientist, maybe for some people it's not relatable. So that was very effective.
Many times the beautiness is in the background, but we just pay attention to the images. I think you never know where the discoveries are. That's why, for example, well, I'm at CERN, there is this thing that we are not discovering anything on the past years. Yeah, Joao knows about it. But still, I think research is still really important to try to find these new discoveries and to understand better the universe.
Not a question, just a compliment, if you allow me. Great storytelling, great time management too. Like you did it before the 3 minutes, and you managed to tell a complete story from beginning to the end with a very simple use of a prop that is very familiar to everyone. Fantastic. Congratulations.
Thank you so much. Hello.
Hello. Okay, it's my turn to not be nice. No, it's really support everything that's been said already, but I was just thinking, a year from now, as I'm looking forward to FameLab starting, so a year from now yesterday, what would you like me to remember from what you've presented as I think back to this year?
I think I would like you to remember, I think the most beautiful part of my talk, and maybe I'm biased because I was working on it for weeks, I think it's the part of tripping over it. The fact that it's an accidental discovery and that something accidental is so important to the universe and is basically the farther we can go in the past of the universe right now is that. There is the case that we could find the neutrino background, which is just 1 second at the Big Bang. This one is 380,000 years after it. But for now, this is the oldest we can go. So for me, that's the most beautiful of it.
Thank you. All right, now I'm inviting the first woman on the stage tonight, except myself, of course. Charlotte Sutter. She is a PhD student in forensics genetics at the University of Zurich. Charlotte Sutter earned her degree in molecular medicine from the Medical University of Innsbruck, Austria. For her bachelor's and master's thesis, she focused on sequencing protocol optimization and forensic age estimation based on DNA methylation at the Institute of Legal Medicine in Innsbruck. Since 2022, she has been a PhD student at the Zurich Institute of Forensic Medicine at the University of Zurich, where her research centers on DNA methylation applications in forensic genetics. Her work includes methylation-based age estimation of stain donors and whole methylome analysis in cases of sudden unexplained death. True to her studies, her talk carries the title, How to Catch a Criminal.
I did not realize how many technical terms I put in that introduction. I will change that now. Don't worry. Give me just 1 second. All right. Imagine a typical crime TV series. Maybe CSI, Bones, NCIS, doesn't really matter. At the beginning of such a series, there will be 2 detectives standing over maybe a dead body. They will also find some sort of evidence next to the body, maybe a bloody knife. And they will think, well, probably the murderer used this knife to kill the person in front of us. over the course of the series, the two detectives will go to some sort of laboratory and ask a person in a white lab coat to please identify the murderer based on the DNA on this knife. The person in the white lab coat will look at the knife for about 5 seconds and will then exclaim, "We have a DNA match, we found our killer." Have you ever wondered how that works in real life? What that even means to identify someone through their DNA? Let me explain this to you. So, at the beginning of every criminal investigation, there is some sort of evidence, maybe a bloody knife. But even more importantly, we hope that on the knife, we find a little bit of DNA from the criminal we're trying to investigate. Now, what is DNA actually? DNA can be thought of as the brickstone of life. It's what makes us us. It's genetic material that encodes who we are, what we do, and how we look like. Interestingly, 99% of my DNA is exactly the same as yours, and everybody else's. The 1% that's different between you and me, however, that's unique to every human being, that is what we're now interested in and what we will use to identify our criminal. Let's say we have the DNA of 3 random people. We have established that it's their DNA, and we can see the DNA looks exactly the same, except for the parts in green, in red, and in blue. Now you might wonder, okay, but how does the DNA of 3 random people help us solve our case now? This is where the actual evidence comes in. So let's say we have this bloody knife, we bring this knife to a person in a white lab coat, let's say to me. I will do a lot of fancy things with this knife in my laboratory, and at the end of the day, I will be able to tell you whether the DNA on this knife has this green part, the red part, or the blue part. Now let's say we did all this, what happens now? Well, first of all, let's look at our evidence. So on our bloody knife, we actually did find a little bit of DNA, and the DNA on this knife has this same green part as my DNA has. This means that this knife could not have been used by this person or by this person, but that it must have been me doing something with this knife. Congratulations, ladies and gentlemen, you just identified a criminal. Thank you very much.
I love it, Charlotte. It's a fun fact. I've got my 90-year-old father staying with me at the moment, and he's a forensic scientist. And watching him 40 years ago on British TV try to explain DNA analysis still gives me nightmares. So, well done. You did so much better.
Thank you.
Quick question for you, and that is, how do you see the future? If we were to go forward 10, 20 years, what will be the impact of what you've been talking about?
So, it's very interesting. So what I had talked about is what is currently being done. So this is really used. What you're seeing in the crime shows is obviously exaggerated because it's a TV show, but it is what's happening. What's interesting for our field scientifically in the future, I think, is what we can do beyond the simple identification of someone. So for instance, you know, we had these 3 people for which we know the DNA. But what happens if the DNA on my knife now had a violet part, or I don't know, yellow, or, you know, figuratively speaking, some other color? And this is where other analyses come in, where we do something else with this DNA, where we can, for instance, predict how someone looks like, what skin color they have, what eye color, what hair color. And that is something that is being worked on, and that is, I think, what will take this field to the future eventually.
Thank you, it was great. At first, I want to ask about this topic you told us already. What do you think are the risks of like having even better and quicker analysis in the future?
Well, obviously there's always a little risk that you misidentify someone, of course, that you thought you caught your criminal, but you did not because of something that happened in the lab, which is always a concern on a day-to-day basis as well, and which is why there are a lot of steps being taken to ensure these things don't happen, so that you double check results with other people, that you do more analysis, that you don't just confirm that someone did something based on one thing that you looked at, but that you do a lot of things, that you also include other fields, because forensic science is a huge field. It's not just this DNA part that I talked about, but there are so many other things that also play into that. And so this kind of combination of many things together is, I think, what we hope will prevent the worst errors that could happen.
Thank you.
Can you show me the knife again, please?
With or without the DNA?
No, it's okay with blood. So the blood is from the victim. So
Yes,
to identify.
could be, for instance. Could also be from the killer, because, you know, sometimes sharp knives also you cut yourself.
Okay.
Either one can happen, yes.
Because I assume it was from the victim. So
Absolutely
maybe
can be.
there are some cells, like skin cells of the
Yes.
criminal on the
So
other
imagine
part.
you hold your knife,
Yeah.
and that would be what the killer would do, right, to stab someone. And this is exactly where you would find the DNA from
And
this person.
what if the killer used gloves? Is it still possible?
That is a very interesting question. Well, there's one possibility. You look inside the glove, because interestingly enough, many criminals, especially these days, also because of TV shows actually, think about that their DNA could be somewhere. Then they wear gloves, are thinking, oh, we're very smart. And then they throw the gloves away very closely to the crime scene. And inside this glove, there's still DNA. And this has happened before, that you then could identify someone from inside the glove.
I am very sorry, but I'm going to tilt you a little bit on the side of science and towards the sociological implications of this kind of methods. So we hear a lot about ancient crimes that were unsolved for decades sometimes, that have been solved recently because, well, we now can do that kind of analysis. And some countries are even thinking about doing, or even doing, DNA databases of their citizens. Of course, they start with criminals, and then at some point it can be a more generalized thing. Do you have any thoughts about how pernicious that kind of science can be to shape the future of our societies?
Obviously, as you correctly stated, putting everybody in a population in a database is a stretch and something European countries are definitely not doing, but some other parts of the world might be thinking about it, as you correctly said. Now you have, maybe for easing your concerns about this, if we talk about this kind of analysis, we're not talking about the whole, like all of the DNA that a human can have that we are storing in such a database. But we're only talking about very, very small kind of pieces of it, which are not informative about who you are, how you look like, what you do at all. Which means that from this information alone, you cannot really say anything about that human being. If we're then expanding and having other methods, as we talked about earlier, where you do store such information, that can become a concern at some point. But fortunately, I don't have to think about this. So I'm kind of glad that someone else has to worry about these concerns, which are valid concerns, of course. Yes.
Thank you. Thank you. It's all right. Gotta work here. Okay, our next speaker is Monica Chano Changtam. She's a postdoc in neuroscience at the EPFL, and she's done her master's in neuroscience with her PhD topic in stress resilience research. Currently, she's a postdoc at the E.P. EPFL, working on the epigenetic clock. She's also founded a science communication channel for communicating stress research in a funny way. So I'm very excited to listen to your talk afterwards. The title of her talk is quite ominous, Shapeshifters.
Hello, can everyone hear me? I have not started yet. What if I tell you you're a shapeshifter? No, I'm not talking about werewolves. I mean, if there are any werewolves right now, your cover is not blown yet. Not yet. Right now, I'm talking about something that's happening inside you. Everyone is shifting in something. It's happening right here, inside your brain. There are cells inside your brain that are changing its shapes and connections just so that it can encode me inside your memory. Now, when they form the connections, the memory becomes stable. But forming these connections and stabilization of these memory can become harmful in cases where you have faced trauma. Let me tell you the story of Anna, a bright, beautiful 25-year-old girl. She loved autumn so much because she loves colors, yellow, blue, orange, red, and the sun coming through these leaves, and she could just sit in hours in the autumn trees. But this changed 2 years ago. 2 years ago, she fell down a trench, and afterwards, she cannot go out anymore into the autumn light. She doesn't feel that autumn is beautiful anymore. It is a fear cage for her because the connections that stored the traumatic memories in her brain became so strong that any neutral signal, any beautiful color becomes a grave fear memory for her. Now, doctors are trying to rewire her connections in the brain by something called exposure therapy. And I hope that one day she'll be able to see the sunlight in autumn as a beautiful thing again. Just because I talk about Anna doesn't mean that you guys do not suffer from it. Have you ever heard of the phrase, "We have always done it this way, why change?" That's your brain connection telling you it's an error because there is a connection existing. Why change? But change is the fundamental basis of nature, and we have to survive, and we have to change. So today, in these times of change, I bring you the gift of knowledge that we are shapeshifters. We can shift the connections in our brain, and we have to use it to our maximum potential so that we can ace in life. That's it.
So, Monica.
Yes.
Great storytelling, but you didn't tell us exactly how that shifting happens and how you can reverse it.
Shifting in the brain?
Yeah.
The cells inside the brain can change its shapes and connections can be formed. And these connections can sometimes become so stable to form a memory. But when you are exposed in this exposure therapy to a situation which is similar to the traumatic situation, for example, in augmented virtual reality, you can have a scenery of an autumn environment, but still trained in a way that the person knows that it is safe. You expose yourself to such situations again and again, and after a point of time, you'll begin to learn that autumn colors are safe again. So that's just changing the connections in your brain by re-exposing you to a situation where you faced a trauma, but this time in a safe environment. Did I answer the question, or?
Yes.
Okay.
I had a similar question about what that meant for me, but thank you. Can you talk a little bit about exposure therapy? Because I thought that had gone through a lot of changes recently and didn't have the same level of credibility and regard as previously. Is that true?
So exposure therapy, trauma is complex, first of all, and every person has a different way of responding to exposure therapy. The traditional way of exposure therapy is, of course, trying to simulate the situation in the brain of the individual. Now, psychologists try to do it with just talking of a scenario, but now we have virtual reality incorporated in the system, we think that it would advance things more. It is true that exposure therapy, after people go exposure therapy, there can be relapses occurring after a point of time. And we believe that it's because the connections have not been fully reverted properly. And these could be because we are not tailoring the exposure therapy to the specific needs of a person. We are going for one-size-fits-all principle, but this doesn't happen in reality. And that's why I think exposure therapies still needs to be improved, and with the advancement of AI, I think we are getting there.
One didactical question. What was representing your prep? Like the...
This one?
Yes.
It's to show you about connections and the shifting of the connections. And of course, the most important part was to show you that the connections in Anna's case became super densely connected. And when the doctors are trying or giving her exposure therapy, it's to unwind the connections so that she can form, and one day she will be able to think that autumn is beautiful again.
Thank you.
Thank you, Monica. I didn't quite understand. Is it right that these, not how do you say?
This one.
This, yeah. Does it only happen when you have a trauma, or is it after a traumatic event, or can it happen after some other, I don't know, psychological effect or in everyday life?
Yes.
I didn't quite understand that.
So right now when I'm talking to you, you're still forming connections inside your brain. And the connections being stable is important for the memory to last. But when I say about trauma, it's because the memories last in such a way that it incorporates every kind of neutral signal into this collection of connections that one cannot think anything outside of the fear anymore. Connections do exist. Right now you're forming connections. It's only about the pathological connections that are very hard to unwire. But then again, giving you the example that of a seemingly normal situation where we don't want to change anything, like we say, we have always done it this way, why change? That's also a little bit of a problem where the connections have become super stable. Of course, this time it's not about fear, but it's about being habitual about something. But to change it, one also needs the same kind of rewiring strategy. Yeah.
Thank you.
Okay.
Thank you, Monica.
All right, our fifth speaker is Leona Knüssel. She's a PhD student in statistical genetics at the University of Lausanne. Now a PhD student in the field of statistical genetics at the University of Lausanne, her academic journey started with a bachelor's degree in psychology at the University of Bern and a master's in neuroscience at Trinity College in Dublin. Meanwhile, she enjoys getting involved in organizational tasks, organizing training camps for youth and sport Switzerland from 2014 to 2023, and now is a student's representative of the quantitative biology PhD program at UNIL. Whenever not behind the screen, she can be found skiing, running, cycling through the Alps and looking for pizza, which I totally get. Title of her talk is Things to Learn from a Switchback to Albula Pass.
A split second later, I found myself in much less pain, but much less shock than I had anticipated. And I would spend the rest of the night thinking, how on earth had this happened? In very brief, I had underestimated my speed and underestimated the turn that was right ahead of me. In the first moment, I concluded the speed issue, the first part of that sentence, must have been the main problem. But why? Why did I underestimate the speed? Well, there's this concept. It's called retinal velocity adaptation. So the cells, the receptors on our retina, tend to get tired when they are stimulated in the same way for an extended period of time. And I have been descending for a while. You know, I've been fast. It's been a nice and smooth and fast descent. It was nice. And my receptors did surely get tired. Maybe you notice when you're on the motorway driving at 120 for an hour, and then you get off the motorway and you go into an inbuilt area, and all of a sudden, those 50 kilometers per hour feel so weirdly slow. That's exactly what I had experienced. I had been riding my bike fast and nice and flowy, and those 30 kilometers per hour at which I hit the switchback, they did feel weirdly slow until I realized I wouldn't make that turn. Well, but that was only the first part of the answer. When I started thinking about what to talk to you today, I realized there is a second part. There is the element of anticipation. I had underestimated the turn. But why had I underestimated the turn? Because I had made an experience before. I had been descending for 6 kilometers smoothly, fastly, at night, no car, no bike, no challenge. My brain, my prefrontal cortex told my lower regions, guys, we can chill. This is smooth. These are finally some fast kilometers without thinking, without worrying. And my lower regions were like, okay, fine. Motor system, not quite so prepared. Visual system, not quite so focused. And well, I hit the deck once again. So what did I learn from this switchback on Albola Pass? Number one, more on a personal note, usually it doesn't hurt as much to fall as I think it will. Second, more importantly, the visual or the retinal velocity adaptation that I mentioned earlier is a thing, and it can actually be dangerous. Third, as a human, I remain curious. I remain thinking about the experience that I make and the things that happen in my life, and the more I think about them, the more new information I can integrate into understanding the world. And last but not least, I may not be the only one who needed this reminder that our experiences shape our perception. Thank you.
Okay, so similar question to the one I asked earlier contestant. Practically, impact on me. What do I take away from this, and what would you like me to be doing differently based on your insights?
Well, I mean, depends on whether you ride bikes or not, but assuming you drive a car every now and then, I feel like it's a really real-life example of how your perception of velocity is not stable. It changes depending on what you've experienced before. And I think we all, I mean, I'm pretty sure everyone who drives regularly has made this experience, that you get used to a certain speed and it feels slow afterwards. And knowing this, I think, really helps us to adapt our speed in a manner that reduces risk for those around us. So to me, it seems like a pretty close real-life example, I guess.
Thank you so much. How do I explain my 3-year-old that he cannot ride his bike at the speed he does right now?
Well, depends. Is the goal specifically to teach your 3-year-old not to ride the bike, or is the goal for the 3-year-old to understand retinal?
Yeah,
okay.
to understand.
I think I would just let him fall, to be honest. I would just let him fall. In personal experience, I feel like this happens to me every 3 years that I have an accident. So I feel like, you know, experience shapes behavior.
Thank you.
Thank you for your presentation. I really appreciated your practical example, and then you went into the theory, so it was really relatable. And I had some bicycle accidents. They were not spectacular, but so painful. How did you manage to fall in a good way, in a not hurtful way? Because you said you have experience. Every 3 years you fall, so...
Like, number one, wear a helmet. I feel like so many times I thought, I'm so glad that there was something between me and the road. Number two, this time it was night, it was really cold. I was wearing layers, so my skin remained intact. That really helps too. And then number three, I think it's pure luck, to be honest. I mean, I did, you know, don't get me wrong, I was bruised, but way less than I thought in the moment that I was falling. So maybe it's also just about expectation management. Like, how much should it hurt, kind of.
I'm also asking because when I was a kid, there was a friend of mine, he was like a cat. And we were playing like pushing this supermarket trays and then going onto the walk. And he was just popping out and like a cat rolling. I don't know if you developed such a skill.
I don't have the skill, but maybe we should ask your friend to, give us a session on that.
Yeah, somewhat related. I'm a gamer. I play games. And I noticed, I play with my team. I hope my boss is not hearing it, but we play at work. And I notice, we all comment this, like sometimes after playing certain fast-paced games, when we go home, well, I tend to drive a little bit more aggressively than I should, Is this a kind of adaptation of that kind that you're talking about? And what do you suggest that can be done to mitigate that, even for very mundane practical uses like riding a bike or just being in the motorway?
Okay, so I think the type of adaptation is slightly different from what I've just been talking about, because the retinal velocity adaptation is really specifically the receptors that get tired. It's like if you look into the light for a moment and then you look away, you're going to have this afterlight. That's because the receptors get tired, and the same is true for those velocity detecting receptors. And what you're referring to now is more a higher level kind of adaptation, that higher ordered parts of your brain seem to get used to something and then to kind of become too adapted, right? They kind of become too relaxed, even though maybe they should kind of give you a warning that this now is real life and there's a real danger, right? So maybe, I don't know, meditation, maybe to just take a moment to sit down, and get your brain back to normal state between gaming and traffic. I don't know.
Thank you, Mom.
Sorry.
Thank you, Leona. Next up is Yves Rudin. He is a student at the environmental toxicology at the University of Applied Sciences and Arts in northwestern Switzerland. He is currently in his 4th semester at the FHNW, studying environmental technology. At the moment, he is particularly interested in toxicology, and in his free times, he enjoys bouldering or climbing and tries to appear and be open and honest, but always with a touch of humor. He signed up to FameLab because he wants to improve his presentation skills so that he can convey his knowledge clearly and with humor in the future. And is also interested in discovering what else is happening in the world of science. So you're definitely at the right place.
You can still see me. Do you hear me? Yeah, you do. Okay, great. So I think we two are ready. Yeah. You know, Jackie, I like convenient things, right? Things that just work. Just like my rain jacket. It keeps you dry no matter how hard it's raining. Or the convenience of cleaning my non-stick pan because it rarely gets any stains. And this is all possible thanks to the PFAS. The unsung hero, really, of modern day convenience. But it gets even better. Did you know, Jackie? You also could coat a door in PFAS to make it fireproof, so it even can save your life. And the great part, it's a whole group with our 15,000 different structures, each designed to make your life more convenient. What's up, Jackie?
I mean, that sounds great and all. But you know, this group is also called forever chemicals. And you know why? Because we find them everywhere. Really, it's hard not to find them. And they hardly degrade. I mean, they're in water, soil, animals, even in humans. And there are some studies that show they can impact your hormonal system, your immune system, like vaccine response, and even promote obesity. So I don't know how convenient I should find those.
You got some points there, Jackie. But you know you can divide the PFAS into 3 groups when it comes to degradation speed, right? Some think around 30 years, others 50, and yeah, the tough ones they're around for some time, 100 years. So in those studies you mentioned, those are animal studies, right? So the translation from animal to human isn't that easy nor straightforward. And Jackie, as I said, we have 15,000 different structures. So we could just choose the most convenient ones. I mean, we could, but I don't see that happening. And if we continue like that, it's going to affect our immune system. And then a simple virus could knock you out for weeks, and you have to get more vaccine shots just for the same protection. And on top of that, you maybe weigh 10% more. I mean, this whole virus thing and vaccine thing, you know how this can turn out. Maybe we just ban them and be done with them. Yeah, ban them and be done with them. I mean, this could be a possible solution for this potential future scenario, which, by the way, we don't even know if it's going to happen because we lack the data. But what's going to happen? PFAS are going to affect us in the future, no matter what. So we have to do something now. And maybe we just ban them all at once, slowly reduce them, or conveniently pick them. We have to do something, because with all this other stuff going on in the world right now, our window of opportunity is closing, and that fast. So the decision has to be made now, and we have to do something. So the next time you hear a conversation about the PFAS, maybe you already thought for yourself, where do you use PFAS? Do you really need them there, and how could you reduce them yourself? Thank you very much.
Thank you both very much.
You're welcome.
Are you familiar with the concept of the luxury trap? This is something that I remember hearing about with regard to my island, England, which was conquered by the Romans, and it wasn't through so much military prowess, but through luxury baths and roads, and the fact that this wild, warlike nation succumbed because they liked a little bit of comfort.
Yeah.
How easy is it to get people to give up convenience?
Ooh, I guess that's the hard part about it. I mean, convenience, it can start easy, right? Just buy a stainless steel pan, for example, instead of the non-stick pan. But if you scale it up and say, yeah, you have to produce, I guess, some special oils that you need in the industry without PFAS, there it gets tricky, because those oils to run a machine are very important for, I don't know, your car, your iPhone, a plane. So those are challenges. And yeah, the debate is still roaring. And I guess you can substitute where you can substitute, or you should, and people are doing that. But we're still waiting for the big solution, you know, to replace PFAS in more important parts of our industry. So it's hard. I guess that's the message. But I think people are starting to realize that. So I guess on a lower consumer level, rain jackets, pants, and stuff like that, there is a change. I mean, there are also bans in impregnation sprays for rain jackets and stuff. So it's coming along, but the question is how fast, you know.
So you talked a little bit about consumer choices, which is something that we all as consumers can do. And now in your previous answer, you talked a little bit about something I wanted to ask you about, which is political choices. Because one thing is what we decide to do to mitigate this problem. Another thing is what instances that are bigger than us, that like, well, industrialists, like politicians do. I'm wondering about the consequences that a full ban on PFAS could have for the economy and, well, to the structuring of many activities that we take for granted now in the future.
I guess bans will have an impact, but then I guess I would ask the question rather, okay, where do you use PFAS and for what? Mostly just to produce stuff, to have more of that. And then I would ask the question, do you really have to get more of that? So it's rather not like a banning choice, sort of. In the end, it will come down to, yeah, we're just going to ban them and reduce them and you can't use them anymore. But you have to get the people with do you really need that? Do you need more of that? Well, because the market rules, you know? And if the consumerism goes down because people think, okay, I don't need that anymore, I can buy something else or really use it until it breaks down and I can't fix it anymore, then the market will sort of solve it itself. So I guess you can't just swing the hammer and ban them, but then people will go nuts. So you have to sort of shift the perspective of consuming, I would say. Or that's the question you should ask. Does this sort of, yeah.
I like your answer.
I liked how you showed two views on a single topic through this puppet. And I would like to add on what you lastly said, like how is it possible to make this shift in the consumers or to favor that?
Conversation. Transparent conversation, I would say. Like, I mean, I talked about the downsides, like it could impact your immune system or your hormonal system. It can promote obesity. And I mean, those are scary topics, right? You don't want to think, oh, I'm just getting larger because I don't do anything. But it's an important part. You can grab attention, but then you have to go into the conversation and say, okay, we find them there and here, and concentrations can differ, and just clearly talk to the people and not just swing around, oh, you're gonna die because of them, or you can't get any children, and if you ban them, the economy is gonna break. It's not that harsh. So I think a transparent conversation is really important on this topic. I guess you can catch the people with drama. That's nice, but then you have to sit them down and talk to them. Like, okay, this is what it looks like, and this is reality. So I would say transparent conversation.
I would like just to add one thing, because when I take the train, the tram, I see less and less conversations. Like sometimes I look around and I'm the only one not using the phone. So I don't know how to have more conversations.
Do you know Veritasium? It's a YouTube channel, very big. I mean, he's making YouTube videos, he's talking to people, and if you watch your phone, he's breaking it down. He shows the negative aspects, the positive aspects, and he talks sense, so to say. So, okay, that you can do. So he is providing transparency. So I guess you just have to figure it out where you can get this transparent conversation from. And I mean, you could just walk into the streets and talk to people. I mean, if you're motivated or have an afternoon of time, that's probably another way to do it. But I guess if you use social media the right way, there is much potential for that, I would say. That's my opinion.
Thank you, Yves. I also liked the picture of the dialogue, which you implemented very well. I also wanted to ask about how to start such a conversation, because I made the experience that a lot of the times people then only have like black and white opinions and very quickly drift apart.
Yeah.
And I mean, that's a problem of our times, but maybe you thought about that.
I mean, I thought about it, but I guess I'm really desperate for experts like you guys who know how to talk or like to get it to people, because that's a point where I fail sometimes too, because I talk to people, I see the needs of it, but then I'm just rambling and rambling and rambling, and you know the world is gonna die, and we all, and then they're like, So it has to be taught. You have to understand it, and it's hard. So I don't know, maybe walk to them and say, okay, look, it's not that bad, and sort of smooth them in, but that's a point where I struggle too. So maybe you will figure it out, or I will figure it out, but I'll send you a mail or something if I figure it out.
Thank you, thank you. I think we should all listen more. That's the starting
that's
point,
a good
or
beginning, I would
just learn to listen again.
Yeah.
Yeah.
Great. Yeah. Thank you.
Thanks.
Thank you. Wow, that was a deep dive into science communication. It's a huge field, just so you know. And nobody has the answer, so. Our next speaker is Tania Barat. She is a PhD student in ecology and evolution from the University of Bern. Tania has always felt at home outdoors for as long as she can remember, poking around in marshes, squinting up at birds, and somewhat obsessed with leaves. Her fascination with the natural world led her to pursue biology at the Indian Institute of Science, Bengaluru, followed by the MEM Masters in Evolutionary Biology. For her PhD, she's exploring how biodiversity can adapt and stay resilient in changing worlds. She's passionate about making science fun, accessible, and inclusive. Welcome Tania and her talk, Aquatic Alliances, Who Shares the Helm of the Deep?
Or maybe I just stand here. It's okay. Yeah. Thanks. Okay. Yeah. To live is to live together. As humans, we gather in families, in friendships, in sprawling societies. And in nature, it's much the same. From ant armies to elephant herds, from fish shoals to bird flocks, it's nearly impossible to find something that lives completely alone. But why live together? Because the perks are plenty. Safety in numbers, efficiency in finding food, support in raising young. However, even three is a crowd, and you quickly invite confusion, conflict, and sometimes even chaos. And that's when you need leadership. So what makes a leader, you ask? Well, in animal groups, it is usually the individual who consistently influences the behavior of the other group members and often stands out from all other group members in either its motivation, personality, or knowledge. Take migrating wildebeest, for example. Here, it's the individuals with the knowledge about the grazing routes that guide the herd across the savanna. But one of the most fascinating examples of leadership comes from the ocean. Picture the big blue octopus drifting through the Pacific and the Indian Oceans. This octopus, instead of hunting solo, often associates with several kinds of fish in hunting groups. And researchers from the Max Planck Institute of Animal Behavior dove in, literally, to learn more about these strange alliances. They used scuba and three-dimensional videography to track these individuals. They monitored the spatial positions and the behavior of every group member for over 120 hours. And what they found was striking. These groups were not controlled by a despotic leader, nor were they drifting about aimlessly. They were practicing something else, shared leadership. The octopus was in charge of deciding when the group moves to a new hunting ground, while the yellow goatfish was responsible to decide where to go, in other words, the direction of movement. And this is remarkable because whether in boardrooms or the bottom of the ocean, leadership is not always about dominance. It's about knowing when to lead and when to follow, because good leaders don't just command, but they also collaborate. So the next time you have to make a leadership decision, you can remember the octopus and the goatfish, because the best way forward is to share the steering. Thank you. Thank you so much. I think everyone now has a picture in his mind of some real-life situation where we can implement your science. Mm-hmm. That's great. Thank you so much.
I would like to hear a specific example with the octopus and the fish.
Okay.
Like, if it's possible, like on how, depending on the prey animals, I think, no? When they
Yes.
go hunting. So,
Yeah.
like, how do they, like, do they push them in a direction, or how they coordinate?
I was wondering, I mean, I didn't have time to include this bit, but so what actually happens is there are several species of fish, and this is just one of them. And what happens is this fish goes away in one direction, and then, so the rest of the group is here, and then the octopus then decides, if it decides to stay, then nobody moves. So if the octopus doesn't move, nobody moves, and then this comes back. Whereas if this goes away and then the octopus starts also moving, then the rest of the group also follows. They also have videos, and it's super cool to watch them. Yeah.
Well, I'm learning stuff, lots of stuff in all these presentations. I'm wondering if there are many other examples in the animal world of that.
Yeah.
And if you find, so in this case, you had the example of the shared decision between direction and time. If there's other variables that you find in the animal world, and if there is a pattern for that, like a wider pattern.
So there are general patterns that you can find. Some are, for example, matriarchal, like for example, elephant herds and hyena groups are led by females, often one dominant female. So there are different kinds of societies, almost. But this, I think, is an especially, like, it's a particularly cool example to me because often, most of the research that's happened is on a single species. So it's just elephants in the group, or it's just hyenas, or just a single kind of fish. But these are mixed groups, so which is super cool. And it's harder to study them also in a way, because then also how they communicate with each other, because often communication within a species, it could have evolved within a particular kind of organism. But between species also is, I think, more complex and more interesting.
Sorry, just a remark, just an epiphany I just had, a revelation. I just figured out that this also happens in couples. Human couples, a lot. I mean, all of you that are in a couple, if it's a well-balanced relationship, you know what I'm talking about. Wow, mind blown. I have to decide if I'm an octopus or a fish. All right.
Oh, I love this. I love this, and I love what you said. I teach on leadership, and I'm going to borrow you and invite you for lunch or something, because I'd like to go into this a bit more. But just to come back to something you started with, if we look culturally at individualism, collectivism, we see differences around the world. I particularly see that individualism seems to be very hardly rooted, particularly in Western culture. How can we change that and help people to think more collaboratively? Sorry, that's a very big question, but give it your best shot, and that's okay, yeah?
Yeah, I mean, when you mention individualism, of course, there are ways of studying also personality. And some people don't like the term personality, even within the scientific community, when we use personality for animals. But of course, there are set ways to do that. I'm trying to think. So your question was how to make individuals more collaborative.
Make them more like the octopus and the fish.
I don't know, incentivize them somehow? Because, I mean, or you can show them, for example, that if they would be alone, they would get less than what they would get if they were working together. I mean, I'm thinking in terms of evolution here, because these groups won't exist if not for that, like if it wasn't incentivized for them to be like this. So
that was a very tough question, and I like the way that you thought deeply and explored it yourself before you answered. So well done, thank you.
Okay, thank you. Maybe, should I move it back?
Okay, our next speaker is Maud Vernet. She's a PhD candidate in conservation biology at the University of Bern, and she was born and raised in Geneva and moved to Bern for her studies. And in Bern, she discovered her passion for ecology and conservation biology, which I totally get. Bern is very nice. For her master's thesis, opened the door to a PhD, which she's now pursuing under the supervision of Stefano Gannessa at the University of Bern and John Evan at the Zoological Society of London. She specializes in She specializes in species translocations and develops methods to predict potential ecosystem impacts and make species introductions safer. The topic of her talk is, would you invite a kingfisher for dinner?
Thank you. Can you hear me? Okay, great. I'm ready. When species risk extinction, sometimes the only way to save them is to move them somewhere new. But here's the catch. What if the species you're trying to save ends up harming its new home? Think about that new home like a family dinner. Everyone knows each other. Your uncle is wearing his usual green jacket. There's no garlic at the table because everyone hates it. Everything is as usual. Well, expect. Suddenly, a stranger knocks at the door and asks to join. Do you let them in? You don't know if they'll politely pass the salt or if they'll flip the whole table over. Plus, whether they fit in does not only depend on their own behavior. Think about it. Joining a tense dinner is very different from joining a happy one, and we all know that family dinners can go south, even when there's no strangers around. And ecosystems are even more complex. So yeah, telling the future is hard. That's why in my research, I don't try to find that one true future, but rather I try to find all the plausible ways that things could go. Think about what I'm doing, like creating thousands of simulations of the future, like parallel universes, all set up a bit differently. For a family dinner, your simulations would differ by where you sit, what the vibe is, what political debate could arise. And for ecosystems, it's population sizes, interaction strengths, and growth rates. Once you have these universes, you add your stranger, see what happens, and then decide to let them in real life depending on all of these outcomes. Say you made 5,000 simulations of your family dinner, and in 4,000 of them, your mother-in-law stormed out following the stranger's arrival. In real life, do you think you would let them in? Well, probably not if you like your mother-in-law. But if she storms out only once, then maybe you'd think about it if the stranger is really hungry and check up on her during dinner. That's the same logic for conservation translocations. So let me introduce tonight's potential guest, Sihek, a bright, beautiful kingfisher from Guam. Once common, these birds are now extinct in the wild and survive only in zoos, where they are slowly running out of time, out of space, and out of genetic diversity. So researchers thought of an idea, a new home in Palmyra Atoll, in the middle of the Pacific. I made 5,000 simulations of Palmyra of the introduction. And the results? Sihek behaved. No species went extinct, and some of them even did a bit better when Sihek was around. And Sihek was introduced to Palmyra last year. That's why these models matter. They tell you how risky these invitations are, whether to shut the door, put a new plate at the table, or hide the breakable dishes. Because for Sihek and species like it, this invitation can mean the difference between survival and extinction. Thank you very much.
I'm now really interested about knowing how you do these simulations. So what are your parameters? How do you really evaluate outcomes? Is it just statistics? Is it just numbers crushed and you see histograms of outcomes? How does it happen?
So, have you ever heard about ecological ensemble models? Yeah, so probably not, right? That's why I try to not include that in my talk. Basically, how it works is this was developed for at the beginning for a national a national park, sorry, where they introduced wolves, and they knew that they reintroduced actually the wolves, and they know that no species went extinct. So that's what they put in the model in the beginning. You add a species, and you know that everyone comes out of the whole ecosystem and is all right. The thing is that in nature, the biggest thing that dictates how species behave with one another is interaction strength. And this is something that people have been trying to put a number on, or like a way to calculate them, but no one has really made it. So instead of trying to put a number on that, we just make models where we tell the model some of the parameters that we know, like the growth rate of the species, or like how we know like this growth rate is possible. A bigger one or a smaller one is not possible. And we know that there's kind of this number of individuals in the species, not more, not less, but we don't know the right number. And then based on that, the model is going to take all these parameters and create all the plausible starting state of the ecosystem, basically. And then over time, you're going to see all these thousands of simulations. And what you're hoping is that you're creating enough simulations to cover all the possibilities. Have I answered your question?
Yes.
Okay, cool. But I'm happy to talk about it more if you're interested.
I'm thinking about the maybe trial in the past where people introduced a new animal or new species in an ecosystem and then it went south.
Mm-hmm.
Is it possible, like how do you correct that, or is it possible to put a new species to regulate the new one, or it gets worse exponentially? And
yeah,
I'm just interested in that.
That's a big topic. I actually work in invasion science. So basically the science of species exactly becoming invasive, basically becoming somewhere or being put somewhere and then turning into this big danger for the ecosystem. And this has happened in the past. It has happened mostly, do you hear me well suddenly? Yeah, okay. This has happened mostly in the case where humans decided that they really wanted to have something where it didn't make sense to have it. So for example, species that they wanted to hunt and were not present in the ecosystem, so they just put them there. Or they did that and then they realized the species became invasive, so then they put another one thinking that it would help, but then they didn't check if that one would have an impact before doing it. And then this one had another impact, so they put one more to try to make it better. That's exactly how New Zealand happens, basically. What I do is try to prevent that. So it's exactly the goal of my research, is to try to understand that we're at a stage in the world where we've destroyed the ecosystem so much that there are some species we have to either accept to lose them or move them in some cases. And we know that the risks are so big, and so the goal is to try to find that sweet spot between losing a species and not doing anything, or doing something but knowing what the risks are and trying to take them into account in your decision, basically. Thank you for the question, though.
I love the fact that there was a happily ever after at the end, and wonderful thing about that practical application and the home found, which was really nice. Looking forward, thinking about advances in computer processing power, and everybody's raving about things like AI and the like, doing 5,000 simulations, how do you see this work changing in the next decade, and what could be the possible impact?
That's very fun, because it's also what I'm doing right now. So not me directly, because I'm not a pro in computer science in general, but luckily I'm in a science where we're trying to be as complementary with other types of science as possible. So for example, in this work, I work with the people who developed these models, and they're the ones who made it even possible to do 5,000 simulations before. So basically, before they did that, I've done both, so I know exactly what I'm talking about. Before they did that, I tried to do with these 5,000 simulations, and it took my computer, well, my computer crashed, but it took another computer, a bigger one. I think it took 6 days to run the 5,000 simulations, and right before the end, it crashed. and now it took 3 hours. So if that can have, this is not using AI, it's using another method called SMC chains. But if this is possible already now, I think in the future, I don't know if we're going to go below 2 hours, but we can definitely maybe do more. And that's definitely something interesting. Thank you.
And if you can do even more simulations in less time, what kind of new possibilities do you have in your research then?
So many ideas, so many ideas. So basically, once you have all these simulations, you have all the simulations for all the species that interact with your introduced species. And then you see how their abundances change. So if, for example, the wolf, there's more wolf, then there's going to be less rabbits because the wolf ate the rabbits. But then once there's 2 less rabbits, there's going to be less wolves because they have nothing to eat. So you're going to have more rabbits again. And then what I hope to do in the next step is to try to see, like monitor what is happening in Palmyra, for example, in this case, and see what is actually happening. And from this, I will be able to eliminate all the simulations that are not happening. So with that, maybe I can get closer to having a real evaluation of what might happen there in 100 years. And then if we have more simulations, I can only get more precise. So that's
fantastic.
Also something interesting. Thank you. Thanks a lot.
All right, we're slowly nearing the end. For our 9th speaker is Sein Li. She's a postdoc at the University of Zurich in primatology. During her PhD, she followed primates in the rainforest of Indonesia in order to understand what makes primates social. Alongside this, she explored curiosity in both humans and non-human primates, looking not only at how individuals are curious about objects in real life, but also how they are socially curious about others' behavior and emotions. As a postdoctoral researcher, she's expanded her work to study pro-social behavior in humans across cultures and curiosity in both human infants and chimpanzees. Applause for Sein.
Thank you for a nice introduction. I'm not going away, I'm coming back. Okay. Great, I'm ready. Okay, so what is intelligence? Anyone here not want to be intelligent? I see no hands, so of course not. I mean, humans are often seen as mega intelligent. We build self-driving cars, rockets, and even ChatGPT. But on Earth, there are over 500 non-human primate species living, each surviving on their own way. So, are we just looking through these human-centered lenses and become like blind to other forms of intelligence? So, let's take a very special journey to see what happens when we open our eyes. Ready? Okay, I think you're ready. So imagine you can see this, 1-year-old young gibbon, is super cute, living like 50-meter up high canopy in Indonesian rainforest. You get up at 5 a.m. and you pee, you poop, and then you finally get ready to move to another tree with your family for breakfast. So hop. You arrive at the tree, and you lift the leaves up, and you finally find something super weird and colorful. Weird, right? Is it even edible? Well, if you're human, sorry, you're gibbon. If you're human, then we can Google it, or hey Siri, ask Siri. But in the rainforest, there's no internet, no AI, no YouTube tutorials for fruit hack. So just you and this mysterious fruit, right? But there is your brain. So you could do like biting it. Really not a good idea, it's really disgusting. But when you use your brain and find the right spot to crack in, then suddenly food everywhere. So what does a young gibbon actually do in the rainforest? It watch and learn. So mother nearby, she smashes this fruit against the tree trunk to crack it, and dad, like doing a kind of boxing to crack it. I succeeded. And older brother, you should be really careful because he deceives you. Like he pretends like, oh, here is the right place to crack it. And then young poor gibbon get fooled and like, ugh, it's so bitter. It's really bitter. And older brother is so happy watching and haha, the typical sibling thing, right? So over weeks, the young gibbon built a mental notebook who eats what and how, who succeeds and fails, and who deceives you. So that's memory, learning, judgment, and in other words, intelligence. And intelligence is really not a pyramid that humans at the top, because what I just explained is just one primate species, and just a part of what I've actually observed in the rainforest. And on Earth, there are like 500 primate species, and only 5% have been studied for intelligence, and of those, only 1% have been studied in wild. So, still how wild the intelligence can go is mystery. So if we want to see all these wild and beautiful forms of intelligence, we better throw this human-centered lens away and open our eyes together now. Thank you. I'm sorry I made a mess. Okay, I will still keep it because I want to open my eyes. No.
Right. Great presentation.
Thank you. I'll stay here.
All right, so you were doing the parallel between how humans do things and how primates in the wild do things. We have our technology, but I'm wondering about the transmission of knowledge between primates. So if a primate learns something about the fruit or about something in the forest that can be beneficial or not, how do they transmit that knowledge to the others? Do they actually do that?
That's a super great question, and that's my main interest. I will tell you one example. So, recent findings say like wild chimpanzees, they drink a cup of beer a day. It's a bit weird, right? But it means that they actually consume kind of ethanol from ripened fruit. And how they get this knowledge is by hanging out together. So there's like a beer party for them. Like one like, oh, it's so good. Would you try it? I'm like, well, you're my friend. Why not? You're not gonna fool me. Well, indeed, like friends and family fool you, but at least you trust them, right? And like, drink it, and like, it's so good. I should spread this out. That's how the social transmission works. Like social curiosity that I worked with before, that kind of this knowledge actually spread out really fast if it's really beneficial. But if it's not, also in the same way, it spreads out really fast because we need to avoid it. That's what I said when their deception happens from older brother, it also can be transmitted super fast. Like, oh, he deceived me, you better not take it if you're a good, like a gibbon who has a younger brother or sister. But if you're not really good and nasty, maybe it will happen in another way.
Loved it very much, yes. Particularly, I love the aspect of recognizing difference in intelligence. Because of our experiences, this is the way I do it, must be right, and seeing something different in a different context and look at the animal kingdom. What would be, do you think, societal impact on this? Again, one of these really vague, big questions, but just if we could understand the differences and the different way that people are, what would be your dream of how we could change as humankind?
That's also actually what I'm working on as a postdoc, moving to like more human sides. So this understanding that we have different intelligence can be expanded to other aspects. For example, understanding another race or understanding another culture. It can go from micro to like macro. So it's not only just saying like, oh, you're like similar intelligent to me. It's not about this. It's more about understanding which environment this person has been grown up, as we will gonna do with another like non-human primates. So in that way, it may work that, I'm just saying may because I don't have like absolute answer to this. It may work in that way, like for example, I'm from South Korea and I had kind of time to understand what is culture in Switzerland, and it took me some time to understand it, like what's going on here. Even though culture-wise, Switzerland is a bit less studied than other Western countries, but it's a bit somewhere between individualistic and collectivistic. And to me, as a South Korean from a super collectivistic culture, somehow a bit similar, somehow very distant. So sometimes I'm really happy with them, sometimes really not. Like, guys, seriously. But there, I'm trying to, use this understanding from my background. Okay, you're also one of these primates. And I'm going to understand what background made you like that. Okay, now I see. So it should work in this way. Like, if we fail already from between humans and non-human primates, then we cannot go to this side, like between humans. So that's why I wanted to send this message and deliver. And it's not like a teaching, but I hope it's kind of act like after you all leave this place, you think, okay, am I like smarter than chimpanzee? Not in this way, but like, what could be a similarity? What could be kind of understanding between me and all other animals, including all humans? So that would be my answer.
Thank you so much. I really liked the clarity of your words and your visual presentation. It made very clear what your science is about, and I think we all can take something home from your work. Thank you.
Thanks.
I like how you use your prep for presenting, and also a lot of variety. Like, you included your T-shirt, and then a piece that you opened, and then also the glasses to show the numbers or the statistics. So it was very, very nice. And I think because you are from that particular department in Zurich, there was also this famous example of the orangutans, like on one side of the river cracking the hard shell, and on the other putting a stick to get out the fruits. And so what are the conditions or the aspect that influence one population towards one strategy or the other?
Yeah, that's also a very big question. I think it can be also related to this octopus and fish example, because one can lead the way. And for example, here, it's really a bit hard to say who would lead this kind of where to go of the population or the group, because there also should be understanding of social structure, like rank and like personality also, or like how they are related in a like family way, like gene. But for example, it could be, there are like findings say like in their social network, one in the very middle of the network, like super densely connected to other individuals, could be the one who can lead the group to somewhere that the group can solve the problems in reality. And this orangutan, or even like chimpanzees or other monkeys, they also do this. And there would be one individual actually finding this like skills, and then that could be kind of used in other members in the same group. And that way the group can find the way or direction where to go. So does it answer the question?
I'm just, because you said something very, like, it was for me so eye-opening, like also the hierarchical structure plays a big role. And I'm imagining a group of monkeys, and then there is one low in hierarchy that finds a new strategy that is much more effective. So are the other people in the social structure taking him as a role model and also taking this behavior, or are they waiting until, I don't know, the leader or some middle ranked start this behavior to also implement this?
That's also the question I really love, because my beloved colleague is working on that. I really love her. And what she's doing is to see whether like low-rank individual in vervet monkeys can actually find a solution to puzzle box, and then it can transmit it. But the answer is not really the case. You don't have a chance. But that's actually kind of like ringing the bell in our minds that then how it can be applied to our humans. Like, can we say like, oh, you're from like low rank or kind of this like pyramidal social structure, you will have no chance. And if you think about like people who come from really down, deep down there, and then like become a successful person, we applaud them, right? So still in our society also that's happening, that in a kind of like low rank or low, I don't know, in a more like hard situation, they have lower chances to do that. And it's also same in non-human primates. Of course, there will be some social structures with almost no social rank, which should be my case, the gibbons. They're like just family, and there's almost no rank. So in that case, they have all like equal chances. So these findings from non-human primates give us a message that, so what we can do as humans, because I think in humans, there are many societies that with varieties of the social structure regarding like rank, and that can say like, okay, then maybe we need to have more like chances for these people. I think that transferred to policies and so on in reality. And that'd be the kind of things that we need to think more deeply. As for now, I only can say about non-human primate side, but I hope I can contribute to making the world better for humans also. Thank you.
No worries, just take your time. Meanwhile, I will already introduce our last speaker for tonight, Pietro Ronconi. Sorry. He's a first-year bachelor student in communication at the Università della Svizzera Italiana. He's had a Steiner School education for the best part of his life and then decided to take on the IBDP diploma, which he's finished last year, to then start a career in the field of communication in Lugano. He's a driven person, a passionate communicator, but most of all, a curious person with countless interests. He grew up with the love for nature and science and has always considered himself a respectable mixture of intuitive and logical approaches. So applause for our last speaker with his talk about funneling chaos.
Actually, one sec. Just one thing before I start, I want to say that my presentation was written like 8 months ago, and it really wasn't that great. So if you have any questions about my past other than that, ask, because it really wasn't that representative. So, shall we start? What is the most difficult way of becoming rich overnight? Maybe by winning the lottery? Ever since I started loving math, I know my answer: solving a Millennium Prize problem, one of 7 mathematical problems so fundamental, a prize of $1 million is awarded to anyone being able to prove or solve them. And today, I'm here to tell you about the oldest and hardest of them all, as well as my favorite, Riemann's hypothesis. Bernard Riemann, the man behind the theory, claimed that inside of a function he discovered called the zeta function, there exists a path which correlates with prime numbers in a completely new way. But unless you're familiar with this topic, this would have sounded like complete nonsense. So let's go at this another way. I invite you to please close your eyes with me, take a deep breath, and relax. Let's go on a short journey. Please imagine you're standing on top of a highway looking down, with many cars streaming down underneath you. Each one of them is a number, and some of them, like 2, 3, 5, 7, 11, etc., are prime numbers, meaning you'll never know exactly where to find them. No logical pattern to them. Now imagine there's a roadwork, our zeta function, which moves all the cars to a single lane. Wouldn't it be easier to know where prime numbers are? Let's open our eyes now. That's the idea, a way to make primes follow at least one rule. And we know for sure that they do not like to do it, because we've been trying to make them do it for the past 1,000 years. So, why should you care? Well, first and foremost, proving problems like these will affect your life in the future. Many fields like cryptography and quantum physics already assume the hypothesis to be true. So if that wasn't to be the case, it could change everything, from the way we detect particles to the way you send messages or protect your bank account. But I feel like we can ask a better question. Why shouldn't you care? Too often we feel distant from problems like these. But the truth is, you don't need to become a millionaire to be interested in mathematics. Instead, as it happened to me after years of hating the subject, you can become interested in this field in a new way, a way that allows you to see it as a way to expand your views on the universe and see the beauty that we still have to discover. A new way to funnel the chaos. Thank you.
So Pietro, but you did not explain what is the Riemann hypothesis.
Yeah, I knew someone would ask. So, I did not explain what the Riemann hypothesis exactly is because it cannot be explained in 3 minutes. But let's give a fast rundown. So, it's one of these 7 mathematical problems, which specifically is concerning a function called the zeta function, which let's imagine it as a bunch of spirals and squiggles. And through that spirals and squiggles, there's a section of it, which Bernard Riemann hypothesized. There's a connection with a ton of zeros called non-trivial zeros. Let's not get into details here, because otherwise we'll get lost, which was the point of the presentation. And these zeros are related to prime numbers in a way that's completely new. So new that it will perhaps allow us to understand where they are, which is one of the main problems in mathematics. And as you may have studied in school or in whatever you're studying right now, if you're studying something, prime numbers are really random. It's one of the most random things that we have in mathematics, which means you never know where they are. Like, you know that one is there and one is there and one is there, but you never know where the next will be exactly. And this problem, if solved, will tell us kind of a funnel, which is why I call the presentation that way, for understanding exactly where they are. Sorry for the microphone. Okay.
I like the metaphor, because without this metaphor, I would have been like, so it's trying to guide the numbers in a way that it's easier to spot the prime number. Well, if you can add.
Yes.
Did I get it right?
Exactly.
Okay. And by doing that, you can crack codes in banks and so on.
Yes, because most of cryptography, for example, is based on the assumption that prime numbers are, you can't exactly know where they are. So if that was the other way around, you wouldn't, like, your bank account could be immediately cracked, because you would know where the next prime number is, which is the base for cryptography.
Can I add one question on top of that? But let's assume that this thing is cracked, like they find out the way. Is it public domain, or is it an organization keeping it secret? And
no, it's probably not something in secret, because the whole thing is so complex that there will be some kind of huge scientific branch that has to overtake it. It's been going on for about 170 years, so there probably won't be a small terrorist organization that is planning to get into your bank account. But if it's more like of a base level of mathematics. If that follows a path that we don't expect, everything falls apart.
Depends if you consider the NSA as a terrorist organization. Because there was the scandal of the elliptic functions that were introduced by the NSA exactly to do cryptography that would make it easier to aim at the prime numbers that we're using for public key cryptography. But let's not.
You touched on this in some of the things that you said, but what would be your solution, in brief summary, to making math sexy?
Well, first, it's a bit worrying that you asked that, because I didn't manage to do it, apparently. But second, I'd say that the best way is to make it either stupid or imaginative. I chose the imaginative path. But the other way, actually you can do both, but the other way would be to actually, to really make it stupid. That's the best way I can think of. That's the best way.
Thank you so much. I liked that you involved questions that really had the audience to think about some things. And I'm not on the team mathematics, so it was really hard for
Don't
me
worry,
to follow the
not
topic,
many
really.
are.
So yeah, but I liked your presentation. I can sure give you feedback on that. Thank you so much.
I was a bit worried that the end result would be, oh yeah, you had a very nice presentation. I have no idea what you're talking about, but very nice.
Sorry. You need to wait more seconds or more seconds. I just have one question, because I'm thinking about the research field. Like, there is the basic research, and there is the applied research, and there is the research in companies where they just protect their findings with patents. And I'm thinking, is it possible to put a patent, because they take the knowledge from basic research and they update it, and they add something into it, and then they patent the whole thing as they added something into it. And I'm thinking about, is it possible that this trend would happen also with this equation? That they patent the equation?
That could happen, but the point is, this problem is so fundamental and so base level that honestly, I don't know, because it could happen either way. I would personally say that it wouldn't happen because it's very theoretical. Right now, I've tried to bring it down and make it concrete, but it's actually really theoretical. It will have an impact, and like it will be significant for many fields, but it is very theoretical. So it will mostly be a work of mind, I'd say. It won't be applying the thing to the other thing and see if it works, because it's a mathematical thing that's applied to another mathematical thing. And so it is very theoretical. Thank you. Have a nice evening.
Thank you, Pietra. And thank you to all of the participants who have been on stage tonight. I've heard so many wonderful talks, and I've learned so much that I couldn't possibly decide on the best. Luckily, that is not my job, that is actually your job, so I'm good. The jury will now take the time during the break to choose the winner based on the 3 C's: content, clarity, and charisma. At the meantime, as I mentioned before in the beginning, you, the audience, also gets to vote on your favorite participants. To do so, you will see a QR code shortly, which you can scan both here in person, but also those following us online. You can scan it and vote. And yeah, we will be back in around 15-20 minutes, so enjoy the break and the apéro, and see you back here soon.
Just a few more words. We have a few snacks in the back, some drinks, and if there is anything else you want to drink, the bar.
Okay. Oops. We are about to enter the most exciting part of the night. If you would find back to your seats. Okay. Now, I'm sure you're all very curious on the winner, as am I. First, the jury will announce the winner and the runner-up, and afterwards I will announce the audience favorite. With that, I actually already hand over the microphone to you guys, if you want to come on the stage, or...
On stage? Okay.
Like all of you can come. You're all important.
Thank you very much. I would like to open this feedback session and then give it further. First, I want to say that it's easier to sit there than to stand here, so you did great. And you have the opportunity to get some individual feedbacks, because this could be very precious for you. And of course, we had a frame, the 3 C's, but our feedbacks are highly subjective. So I recommend you to go to each one of us to get feedbacks.
So we had a great discussion, and we have to say, before we reveal the results, just how impressed we were on so many levels by the presentations. We were particularly impressed with a number of different aspects. The quality of some of the storytelling, the way you knitted together a narrative to communicate something, that landed to us very well. There was some fantastic examples of imagery and metaphors that went through, and the way that so many of you linked the core subject of science with something that had real practical value to the individual, to society, to the way that we think and the way that we see things. Really very good. We also were impressed with the energy that some of you showed and the diligence that you put into presenting yourself. And the mixture of visual stimuli and everything was just awesome. Okay, so top marks to everybody, and we really wanted you to take an opportunity to celebrate how well you did and how well you got that across. It made our discussion difficult, but it also made it very enjoyable. So congratulations, everybody.
Additionally to that, we understand that while being on stage is stressful, you know that you are being judged, both by the 4 people there in the front, but also by the public at home. You put a lot of effort into your presentations. Some of you managed to come with incredible props and scenographies almost for your presentations, which were really spectacular. Also, something that is remarkable, besides your presentation for which you rehearsed and that of course you probably looked at yourselves in the mirror a lot and you ask your mom and your friends like, how do I do and all that, there was the more spontaneous part of the questions after, which maybe you were counting on some of them, but others were very unexpected. And we were also very impressed by how you performed that, and we consider that for our judgment. All right, so shall we announce the winners? I guess we should start by the runner-up, the number 2. The number 2 person that was charismatic, that had incredible clarity on the story that he or she, didn't say yet, presented, that managed to captivate our imagination and stimulate our neurons was, the number 2 was number 2, Lucas. And you won, or?
No, just, no.
No, stay there,
Just stay there.
You deserve, anyone wants to announce, or I go? All right. And the number 1. Would you like to say some words? Or you said already too many words today. You depleted your stock of words for the night. Huh? All right, so the number 1, the one that captivated us all, the one that made us travel through our own past and our present, and that managed to mangle the stage at some point and then cleaned it up after, was Saim Lee. So these are the winners, but thank you very much for all the other participants. You all were fantastic. And of course, we wish you great success for your future endeavors, scientific and of communication.
Yeah. No, stay. Just, you all gotta stay here. Well.
Yes.
Congratulations also from my side to the winner and runner-up. Now for the audience voting, it was quite a close run, and all of you have been busy voting during the break. In the end, it was an extremely close race, but the audience favorite, the person who managed to get the most votes, is actually not here on the stage yet, so that's a good thing. It's Yves Rudin with the talk, The Convenience That Will Last Forever.
And Jimmy.
Okay, now all of you stay on stage. And actually, I ask all of the participants to join us on the stage. Also, Sylvie, if you have time, you are very welcome to join us on stage. And just get here for photo reasons. Now, while everybody is getting into position and practicing their best smiles for the pictures, I'd like to use this moment to thank all of the people on the organizations who have made this event possible. First of all, thank you from my heart for the jury, for staying concentrated, for asking important and very deep questions sometimes, and the tough job on deciding the winner. Thank you very much. Also, a big thanks goes, of course, to the main organizer, Sylvie, and her team from Life Science Zurich. Without them, this event would definitely not have been that well organized. It was a pleasure to be here. It was just wonderful. Thank you. Of course, we also have a lot of other people to thank, mainly also one of our most generous sponsors, the CESAM. It's the European Center for Atomic and Molecular Calculations. And our partners, the Bioscience Network Lausanne, namely Krishna Gachera and Andrea Vucicevic, the Science Slam Club Basel with Jana Tischer and Eshan Amini, Life Science Zurich, the USI, so Università della Svizzera Italiana with Cristina Elia and Sara Perigalli, and the University of Bern, namely Ben Sulzer. Thank you all for your support. And last but not least, thank you to the audience. After all, science communication wouldn't really make sense without an audience, so thank you for being here, for taking the time, for listening and voting for the participants. And if you're leaving here inspired and excited as I am and can't wait to get more of FameLab, then join us for the international competition in Geneva on November 25th. Yeah, information is displayed here, and otherwise check out the website. It would be great to see you there. With that, that is everything from my side. Thank you very much. I think Sylvie wants to say something, and get well home.
There's just somebody you forgot with a thank you, that is yourself. Iris, thank you very much for joining us for this evening. I think you did a great job, and I hope you enjoyed it also as much as I did. Thank you for all of you for being here, for the audience and everybody else. Moritz and team, it's great to work with you, and I hope you'll be on with us next year again. Yeah, there's still a bit of drinks and food, so don't rush off, but I understand if everybody will have to go rather quickly because we all come from Lausanne, Zurich, Basel, wherever. But have a great evening, and I hope to see you at another occasion.